If we look at in this market segment, what is the IoT value chain? We have hardware, which is the initial thoughts in the mindset of people. We have connectivity to connect the machines, to connect the unconnected things, and we have the value-added services. Surprisingly, hardware constitutes 33% only of the value chain. Connectivity constitutes 20%, and the rest is coming from value-added services, which means that there is a huge opportunity that IoT gives for value-added services. If we don't have value-added services, we cannot make good and usable IoT solutions. What are these value-added services, or how they can be? This comes from the connected device platform to make the device a connected platform that can be reached remotely, to do device management remotely, to provide several opportunities for connectivity through different network interfaces. Device cloud is another added value. Connect the device to a cloud service. Application development, of course, which requires APIs for application developers, system integration, and analytics, which is a huge value-added service, which allows making use of big data. The real use of big data cannot be done without efficient analytics, and there are several professional services. So we call the value-added services application enablement platform because that's what enables IoT solutions with the existing hardware. If we look at all this explosion of connected devices, the expected 50 billions by the coming years, we can say that the good news is that everything is becoming data. Everything is becoming data, meaning it's good. We have a lot of data, we have more information, but this doesn't come at the expense of nothing. There are a lot of challenges, as we will see. So we have the acquisition of data. So it's all about data. We need a lot of sensors. We need a lot of small devices, as well as network devices to talk to these small devices and do the data acquisition. And we have analytics that should run on this data to have meaningful information. And we should end up by an action making use of this data and making use of the result of analytics. There should be an action, whether controlling some devices, whether enhancing a service. If we see this picture, we have different IoT segments generating different data. So access to this different data through at different level of the network, starting from an IoT gateway and going to the edge network until the data center. This can enable a plethora of services making use of this big data. But as it is a good news also, it's a bad news. The bad news is that everything is becoming data. And why? For these different challenges. When we have lot of data, which we call big data, we have first challenge that we face, how to turn this big data into small data. We cannot deal with this big data. We need to extract what we need from the big data. So we're facing the challenge of turning big data into small data. Another challenge is moving the data. Moving massive amounts of data is potentially expensive, and at a certain point of time, our network infrastructure will be a challenge in this domain. Another challenge is the security. This data, most of the time, is sensitive data when coming from factories, from industrial environment, from even medical care services. So we will need new security protocols. We will need a lot of security operations to guarantee the maximum security on this data. So we're facing these challenges. How can we minimize these challenges or mitigate it as much as we can? If we look at the fog computing and the edge computing for IoT big data, it's a very compelling solution and being discussed this day to deal with transforming big data into small data, and also to help in this problem